Have lower mid-tier GPUs finally caught up to the demands of modern Linux users? AMD's RX 9060 XT and NVIDIA's RTX 5060 Ti, both with 16 gigs of VRAM, are out in the wild, but now that the dust has settled, which one actually delivers the best experience on Linux? Are the drivers stable? Is performance finally on par with Windows? And can NVIDIA's open source push reshape the landscape of Linux gaming and local AI? I've benchmarked both cards across 20 games, tested compute and content creation workloads, and even ran some large language models to find out which card deserves a spot in your next Linux build. Let's dive in. Hey guys, welcome to Lifting Linux, where we put hardware to the test under real-world Linux conditions. One thing that always bugged me is the lack of Linux-focused hardware review channels doing deep dive performance-based testing like Gamers Nexus or Hardware Unboxed. So I decided to fill that gap, and I quickly learned why it's so rare. It's hard. Originally, I planned for this video to compare a whole lineup of GPUs, not just the RX 9060 XT and RTX 5060 Ti, but once I started mapping out these tests, I hit a wall. Running consistent benchmarks for gaming, compute, content creation, and AI workloads on the same system across two very different GPU ecosystems quickly turned into a nightmare. For example, with the RX 9060 XT, getting top tier performance in cutting edge titles like Doom the Dark Ages, Stellar Blade, and Dune Awakening required using the Mesa Git development driver branch, but that broke compatibility with DaVinci Resolve. It still worked with local LLM inference, but ironically, performance was better on Mesa Mainline. On the NVIDIA side, I was determined to use the open source NVIDIA Open Kernel modules. Performance in gaming is basically identical to the proprietary drivers now, which is promising, but major limitations still exist. The open driver doesn't expose NVENC hardware encoding, so apps like Kdenlive and Resolve can't access it. After a month of sorting through all of that, I decided to scale back. Instead of testing a full GPU lineup, I focused the video on just these two new cards. I narrowed the test suite to three core areas: GPU rendering performance, LLM inference, and a 20-game benchmark gauntlet. But here's the good news. What I learned from this experience will let me streamline and simplify the process going forward. Now that I've laid the groundwork, I'll be able to test future GPUs more efficiently across a range of real Linux workflows and bring you deep dive Linux hardware reviews this platform deserves. Now, after that drawn out intro, I'll keep the spec rundown quick. You can pause here and check out the details for yourself. What I do want to address up front before the inevitable wave of comments is the price difference. When I bought these cards last month, the gap was only about $50, but as of now, it's closer to $100. And yeah, on paper, the 8GB RTX 5060 Ti would have been a more apples to apples comparison based on price alone. But I paid for these cards myself, and in 2025, I'm not spending money on an 8GB GPU, and I'm definitely not recommending one at the mid-tier, so I'm not testing one. That said, I will factor in the cost differential when we get to the final price to performance comparison. Now, quick rundown of the Testbench. I'm using an Asus TUF Gaming B850 Plus Wi-Fi motherboard paired with a Ryzen 7 9800X3D, cooled by an NZXT Kraken 200mm AIO. For storage, there's a 1TB Crucial P510 Gen 5 NVMe SSD. Now, about the memory, my usual Corsair kit was giving me some stability issues on this platform. I happen to have a 32GB kit of Orico Raceline Neon DDR5 6000 on hand. While I don't review RAM, it ended up working flawlessly here. It held a tight CL30 with no issues, something the Corsair kit struggled with on this board. Because this kit and the Montech Century 2 850W PSU were provided to me at no cost, you'll see the includes paid promotion tag on this video as required by YouTube, although nobody paid me anything for this video. Everything else in the system, including both GPUs, I bought myself. For the OS, I'm running the latest build of Arch Linux on kernel version 6.15.2 with the KDE Plasma desktop environment. For testing the AMD card, I used the Arch mainline Mesa version 25.1.5. for Blender and Llama 2, and the Mesa Git 25.2.0 dev branch for gaming, along with GE Proton 10.4. For NVIDIA, I used the NVIDIA Open Drivers version 575.64 for all the testing, which at the time of testing was just one version behind the Windows proprietary drivers. I also updated to the latest CUDA version 12.9 update 1 and used the same Proton version. So let's dive into the performance results, starting with 3D rendering in Blender. I used the Cycles engine with optics for NVIDIA and HIP for AMD. The RTX 5060 Ti rendered the junk shop scene 46% faster than the RX 9060 XT, and it completed the classroom scene 67% faster. That tracks with what we've seen across both Linux and Windows. Most 3D rendering software is built with CUDA in mind, and spec for spec, NVIDIA still holds a major performance advantage here. That's not a knock on AMD's hardware. Blender's HIP support is still relatively new and it's improving, but it's not as fast or consistent as optics, especially in complex scenes. This performance gap shows up in AI workloads too. I tested a pre-quantized 4-bit Llama 2 7B model using llama.cpp, running the GGUF backend with flash attention enabled on CUDA and ROCm backend for AMD. Both cards handled the model just fine, but the performance difference was clear. On the AMD side, using ROCm, I saw around 397 tokens per second during the prefill stage and about 56 tokens per second during generation. The NVIDIA card running through CUDA delivered over 3,400 tokens per second for prefill and nearly 90 tokens per second for generation. That's roughly an 8.5x speed up for prefill and a 60% bump for generation on the NVIDIA side. Now, again, that doesn't mean the RX 9060 XT is that much weaker in hardware. It's more about software maturity. CUDA, again, has been around for nearly 20 years and is deeply integrated into machine learning frameworks. ROCm, while making steady progress, still lacks the same level of optimization and support, especially in community-led projects. So if you're running local LLM inference on Linux and you care about raw performance, NVIDIA still has the upper hand thanks to CUDA's maturity and developer adoption. Now, I didn't fully benchmark video encoding and decoding this time around, but it's worth touching on. Both AMD and NVIDIA support modern codecs like H.264, H.265, and even AV1, but again, the difference is in software support. NVIDIA's NVENC and NVDEC engines are widely supported and stable across Linux tools like OBS, FFmpeg, and DaVinci Resolve. AMD's VCN engine is catching up, but support can still be hit or miss under Linux. For example, while you can get DaVinci Resolve working on AMD GPUs with some workarounds, official support is limited to NVIDIA hardware. That matters if you're building a system specifically for creative work or video editing. So even with similar specs on paper, NVIDIA continues to offer a more polished and reliable experience for content creation and AI workloads under Linux. But the creatives among you already knew that, so what about gaming? Well, I tested 20 games at both 1080p and 1440p, including ray tracing and upscaling benchmarks. Let's jump straight into the charts. Baldur's Gate 3 at 1080p, the RX 9060 XT drops by about 5% on Linux compared to Windows, 137 FPS versus 144. The RTX 5060 Ti, however, drops from 138 FPS on Windows to just 69 FPS on Linux, a 50% loss. This is especially surprising given Baldur's Gate is a native Vulkan title where performance is typically expected to remain consistent across platforms. On Linux, the AMD card outperforms the NVIDIA card by a massive 98.5% at 1080p and 81% at 1440p. Windows performance was close between the two, but Linux clearly favors AMD in this case. Borderlands 3 performance is more consistent here. The RX 9060 XT drops slightly on Linux, 137 to 122 FPS at 1080p and 96 to 84 at 1440p, around an 11 to 12% dip. The RTX 5060 Ti sees similar behavior, falling from 139 to 128 at 1080p, a 7.9% drop, and 101 to 90 at 1440p, a 10.9% loss. In Linux-only terms, the NVIDIA card edges out the 9060 XT by 5.5% at 1080p and about 7.2% at 1440p. In Black Myth Wukong, I accidentally slid the upscaling slider the wrong way with the first set of benchmarks. My bad. So I just repeated it for all the tests, and at 1080p, both cards turn in nearly identical results. The RX 9060 XT gets 55 FPS on both OSs, while the 5060 Ti sees a 24% drop from 63 FPS on Windows to 48 on Linux. At 1440p, the 5060 Ti drops from 114 to 79, a 30% hit, while the RX 9060 XT only dips slightly from 101 to 96. This gives AMD a 21.5% lead at 1440p on Linux. Despite the heavy upscaling, the RX 9060 XT delivers more consistent cross-platform performance. In Clear Obscure Expedition 33 at 1080p, the RX 9060 XT pulls ahead slightly on Linux, posting 99 FPS compared to 93 on Windows, a modest 6.5% gain. Meanwhile, the RTX 5060 tanks under Linux at 70 FPS compared to 92 on Windows, a 23.9% drop. At 1440p though, both cards fall back a bit. The RX 9060 XT drops by 6 FPS on Linux, landing at 61 versus 67 on Windows, a 9% delta, but the NVIDIA card does worse, falling from 70 on Windows to just 52 on Linux, a 25.7% loss. So while AMD loses a little performance at 1440p, it still ends up being a better Linux performer in both resolution. It's another example of how NVIDIA's Linux driver stack still struggles to keep up. Counter-Strike 2, which I only tested at 1080p because I've been told that's the only resolution or lower that people play it at, but it's consistent with what I typically see. Both cards actually run faster on Linux. The RX 9060 XT jumps from 373 to 409 FPS, a 9.6% boost, while the RTX 5060 improves from 373 to 403, an 8% increase. Interestingly, both cards hit the exact same FPS in Windows, but gain an edge under Linux, with the RX 9060 XT barely edging out the 5060 Ti by 1.5% at 1080p. The result is most likely due to the improved Linux CPU scheduler on a CPU-bound title at this resolution and quality level. Doom: The Dark Ages, despite being an ID Tech game, performance wasn't as consistent as you might expect across OSs and GPUs. At 1080p, the RX 9060 XT drops from 76 FPS on Windows to just 56 FPS on Linux, a 26.3% hit. The RTX 5060 Ti, on the other hand, sees practically no change, 71 FPS on Windows versus 70 on Linux. At 1440p, the story repeats. The RX 9060 XT takes another nosedive, down 26.9% from 52 to 38 FPS, while the RTX 5060 Ti holds steady at 48 FPS on both platforms. A rare case where the RX 9060 XT falls short here, with the 5060 Ti outperforming it by 26% at 1440p on Linux. Things flip in Dune Awakening, and also new game. The RX 9060 XT performs slightly better on Linux than Windows at both resolutions, just a 1% bump at 1080p and 1.5 at 1440p. The RTX 5060 Ti, however, takes a big hit. It loses 35% of its performance at 1080p and 15.4% at 1440p. In Linux-only terms, the AMD card outperforms NVIDIA by 27.9% at 1080p and 18.2% at 1440p. Dying Light 2 at 1080p, the RX 9060 XT delivers essentially identical performance on both platforms, 150 FPS on Windows and 149 on Linux. For the RTX 5060 Ti, the drop is more noticeable. At 1440p, both cards experience a more pronounced Linux dip. The RX 9060 XT drops from 95 down to 79, 16.8% performance loss. Meanwhile, the RTX 5060 Ti falls from 104 to 98, a more modest 5.8% drop. So the takeaway, Dying Light 2 runs almost identically for the RTX 9060 XT at 1080p across OSs, but Linux performance drops off sharply at 1440p. NVIDIA's 5060 Ti is a bit more consistent, but still sees reduced performance across the board. Helldivers 2 remains remarkably consistent across operating systems, at least for AMD. The RX 9060 XT actually gained slightly on Linux at 1080p, going from 101 to 102, and again at 1440p, jumping from 88 to 94, which is about a 6.8%. NVIDIA doesn't fare as well. The 5060 Ti drops from 111 to 89 FPS at 1080p and from 96 to 82 at 1440p. That's 19 and 14% drops. On Linux, the RX 9060 XT ends up 14% faster than the 5060 Ti at 1080p and 14.6% faster at 1440p as well. In Horizon Zero Dawn at 1080p, the RTX 5060 Ti sees a drop from 166 FPS on Windows to 123 on Linux, a 26% performance hit. The RX 9060 XT fares far better, dropping only about 8%. At 1440p, the NVIDIA card again suffers a significant drop, down 28.6%. Meanwhile, the 9060 XT dips 7.3% decrease. On Linux at 1080p, the RX 9060 XT outperforms the RTX 5060 Ti by 21%, averaging 149 versus 123. At 1440p, that lead narrows slightly, with the RX card pushing 115 FPS to the RTX's 95, a 21% advantage for AMD. Marvel Rivals at 1080p, the RX 9060 XT holds a small edge over its Windows results, going from 77 to 80 FPS, a 4% gain on Linux. The 5060 Ti, on the other hand, drops by 17.5%, and at 1440p, the disparity grows. While the RX 9060 XT gets a modest 4% bump, the 5060 Ti again stumbles, falling from 83 to 59, a 29% performance loss. Marvel Spider-Man 2 at 1080p, the RX 9060 XT sees a modest performance increase under Linux. It's about a 2.6% gain. The RTX 5060 Ti, however, drops significantly, marking a 23% loss. At 1440p, the RTX 5060 Ti again loses ground under Linux, minus 22%. The RX 9060 XT also sees a slight decrease, 6.2%. Interestingly, 1% lows are identical for both cards on Linux at 1440p, sitting at 46 FPS, indicating a likely CPU or more likely API bottleneck. Still, the RX 9060 XT maintains the stronger average. Metro Exodus Enhanced Edition at 1080p, the RX 9060 XT performs better on Windows, averaging 124 FPS, with Hairworks and Advanced Physics enabled compared to just 92 FPS on Linux, a 25.8% drop. However, the 5060 Ti shows an unusual result. It scores 167 FPS under Linux versus 112 on Windows, and unfortunately, that's because the Hairworks and physics settings, which were enabled for all runs, failed to activate on the 5060 Ti under Linux at 1080p, no matter how many times I tried and reinstalled the game, resulting in an artificially inflated average that mirrors a default run with those features turned off. At 1440p, where the settings work properly on both GPUs, the story is more balanced. The RX 9060 XT drops from 104 to 86 FPS, a 17.3% hit under Linux. Meanwhile, the 5060 Ti goes from 112 to 105, a smaller 6.3% loss. In Monster Hunter Wilds, both cards struggle in this heavy title, but the losses under Linux are heavier for NVIDIA. At 1080p, the 5060 Ti drops from 66 to 53 FPS, a 20% dip. The 9060 XT goes from 70 to 66 FPS, a much smaller 5.7% loss. At 1440p, the 5060 Ti collapses, losing 20.3%, while the 9060 XT holds steady with a minor 5.4% drop. On Linux, the RX 9060 XT ends up about 24% faster at 1080p and 21% faster at 1440p. Red Dead Redemption 2 performance is nearly identical across the board regardless of GPU or operating system. At 1080p, the RX 9060 XT and 5060 Ti both land right at about 170 FPS on Linux. At 1440p, they're again side by side, 85 to 86 FPS. This is one of the best examples of Linux achieving full parity with Windows, and while I wasn't able to test the RX 9060 XT on Windows because, well, the graphics quality slider just decided to stop working, there's nothing to suggest it would change the results much, but I did exclude this title from the overall averages. In Starfield at 1080p Ultra, the RX 9060 XT leads on both operating systems, 78 FPS on Windows and 64 on Linux. The RTX 5060 Ti scores 73 on Windows but drops to 46 on Linux, a 37% loss. The AMD card still takes a hit on Linux, but only about 18%, making it the more consistent performer here. At 1440p high, the RX 9060 XT widens its Linux lead slightly, 70 FPS on Windows versus 59 on Linux. Meanwhile, the RTX 5060 Ti goes from 65 FPS on Windows down to just 41. On Linux alone, the RX 9060 XT outperforms the 5060 Ti by 39% at 1080p and 44% at 1440p. Stellar Blade shows an interesting split. At 1080p, the RTX 5060 Ti tops the charts with 135 FPS on Windows and 115 on Linux. The RX 9060 XT trails a bit, hitting 102 on Windows and slightly better on Linux at 106, giving AMD a rare cross-platform win at this resolution. At 1440p, the NVIDIA card still holds the top spot on both platforms, but the Linux penalty is notable, from 91 FPS down to 81. Meanwhile, the RX 9060 XT manages 70 on Windows and 69 on Linux, virtually identical. While the 5060 Ti wins in raw frame rate, the 9060 XT's consistent performance across platforms gives it an edge for Linux-first gamers. Warhammer 40k Space Marine 2. At 1080p, the RTX 5060 Ti performs well on Windows with 79 FPS, but drops to 59 on Linux. The RX 9060 XT is far more consistent, 72 FPS on Windows and 80 on Linux, making it another game where an AMD GPU runs better on Linux. That trend continues at 1440p. The 5060 Ti goes from 62 FPS on Windows to just 44 on Linux, a 29% drop, while the 9060 XT holds steady at 60 on Windows and 62 on Linux. Cyberpunk 2077 delivered relatively close results across both vendors, but the RX 9060 XT maintains a slight edge overall. At 1080p, both GPUs dip under the Linux. The RTX 5060 Ti drops from 86 to 70 FPS, a 19% reduction, while the RX 9060 XT sees a smaller loss, just under 5%. At 1440p, the 5060 Ti again shows a larger drop, about minus 20%, while AMD only drops about 8%. Across both resolutions, the RX 9060 XT delivers higher average frame rates under Linux, showing more consistent performance than the NVIDIA card. With all titles tallied up, the averages tell a clear story. At 1080p, the RTX 5060 Ti performs best on Windows, averaging 107 FPS, but loses 19% of that performance on Linux, dropping to 87 FPS. The RX 9060 XT is much more consistent, 104 FPS on Windows and 99% on Linux, just a 5% loss. At 1440p, the gap between Windows and Linux widens even further for NVIDIA, 83 FPS on Windows, but just 65 on Linux, a 22% drop. AMD, meanwhile, drops from 78 to 72 FPS, about 8%. So what does that mean? Well, on Windows, both cards perform extremely well and trade blows depending on the title, with NVIDIA usually ahead in raw FPS. But on Linux, the story flips. The RX 9060 XT not only performs more consistently between platforms, it actually outperforms the RTX 5060 Ti in 13 out of the 19 games on Linux. The conclusions? Well, for the RTX 5060 Ti, Linux support has improved, but there's still a significant performance penalty, especially at 1440p. If Linux is your primary OS, this card feels compromised. For the RTX 9060 XT, the Linux performance is not just competitive, it's reliable. While it can't always match NVIDIA's peak frame rates on Windows, it delivers far more predictable performance on Linux, making it the better choice for gamers prioritizing open source platforms. This generation in this mid-tier, AMD wins the Linux gaming showdown, not just for raw numbers, but for the consistency that Linux gaming still desperately needs. However, while a couple of those titles had some minimal ray tracing, let's take a look at a few of them with more demanding ray tracing settings enabled. To assist with frame times, I also enabled the card's upscaling tech for these tests. Wukong, under ray trace settings, NVIDIA shows a clear advantage. The RTX 5060 Ti delivers 49 FPS average and 37 FPS 1% lows, while the RX 9060 XT managed just 25 FPS average with 10 FPS lows. That's a 96% advantage in average FPS and an even more dramatic gap in frame pacing. While AMD does support ray tracing, in this case the experience borders on, well, unplayable without significantly lowering settings. DLSS is clearly a key factor here, offering NVIDIA a pretty massive win. Again, in Doom the Dark Ages, the RTX 5060 Ti comes out ahead, hitting at 53 FPS on average compared to the 9060 XT's 23 FPS, a 130% performance advantage. Even with FSR enabled, AMD cards struggle with real-time lighting effects in this title. NVIDIA's superior ray tracing hardware combined with better upscaling support makes this game far more playable on the 5060 Ti. Dying Light 2 is the closest race among the ray tracing tests. The 5060 Ti delivered 115 FPS average with 89% lows, while the 9060 XT wasn't far behind at 99 FPS average and 74 FPS lows. That's only a 16% performance advantage for NVIDIA, still noticeable but not game-changing. This suggests that in well-optimized engines, AMD's ray tracing hardware can hold its own when paired with FSR, at least at 1080p or with lighter RT settings. Metro Exodus Enhanced Edition is actually kind of heavy on ray tracing, and it shows. The RTX 5060 Ti hits 73 FPS with 53 FPS lows, while the RX 9060 XT only manages 51 FPS average and 39 FPS lows. That's a 43% lead for NVIDIA in this RT showcase. While AMD's result is playable, it's noticeably rougher during complex lighting scenes, which is reflected in the 1% lows. This one's kind of a surprise. Cyberpunk 2077 is one of the few ray trace titles where the RX 9060 XT comes out on top. It delivered 79 FPS on average and 61 FPS lows, while the RTX 5060 Ti managed 63 FPS average with 53 FPS lows. That's a 25% performance advantage for AMD in a game that's often used as a showcase for NVIDIA's ray tracing and DLSS technologies. It's likely that FSR 3.1 improvement or newer Vulkan pipeline updates in Mesa are helping AMD close the gap here, and in this case, even take the lead. So when ray tracing is enabled, the RTX 5060 Ti reclaims the lead with a 43% advantage on average across 5 tested titles. But that's not the whole story. In Cyberpunk 2077, AMD actually outperformed NVIDIA by 25%, showing that in some cases the gap is closing or even flipping. But again, flipping back, I had included Marvel's Spider-Man 2 in the ray tracing benchmarks, but the RX 9060 XT wasn't even able to launch the game with ray tracing enabled. So the final takeaway when it comes to gaming, for rasterized gaming on Linux, the RX 9060 XT is the clear winner. For RT heavy titles, the RTX 5060 Ti is usually the better performer. But the final takeaway for gaming performance is, considering price to performance and the higher cost of the RTX 5060 Ti, in any game at any resolution and on any operating system, the RX 9060 XT is by far the better bang for your buck. That's not the whole Linux gaming story, unfortunately. I can't call myself an honest Linux creator without acknowledging the downside of Linux gaming. I said I tested 20 titles, but the sharp-eyed among you might have noticed only 19 slides. That's because the 20th game, Delta Force, recently implemented an anti-cheat system that no longer works under Linux, and unfortunately, this isn't unique. Games like Fortnite, Apex Legends, Valorant, Warzone, most EA titles, and more still don't run on Linux because their anti-cheat implementations just aren't compatible. And I'm not going to dive into the why that is here. There's plenty of blame to go around, from developers to cheat coders to the community itself. That's a video for another day. The reality is, if any of those games are a core part of your library, then none of the benchmarks or analysis I just presented really matter, because at least for now, you don't have a choice. You're gaming on Windows. And I'm not going to ignore that inconvenient truth, but I'm going to quietly bury it here at the end of the video because, well, retention. I mean, come on, guys, I got to eat. And since we've made it to the end, let's wrap this up with the final conclusion. The choice between these two GPUs really comes down to your specific needs and workflows. If you're building a dedicated gaming rig, the AMD RX 9060 XT is probably the better choice. It delivers better overall gaming performance on Linux, retains more of its maximum performance, and provides the best value if your focus is rasterized gaming. But if your system is used for content creation, compute, rendering, encoding, GPU dependent development, scientific workloads, or AI workloads, then the NVIDIA RTX 5060 Ti starts to make a lot more sense. CUDA's maturity and widespread adoption still give NVIDIA the edge in non-gaming tasks, even if that comes with a higher price tag. If you use your Linux system for both work and play, well, things get a little more complicated. Performance might not be everything. Driver complexity can be just as important. In my testing, I needed different versions of AMD's open drivers depending on what I was doing. Mesa Git delivered the best gaming performance, but I had to drop back to the mainline for stable LLM inference and If I wanted reliable video encoding or editing in something like DaVinci Resolve, I'd likely need the Pro drivers, or at least hope that VCN support played nice this week. On the NVIDIA side, I was able to use the open drivers for gaming, rendering, and AI without issues, but I still had to switch to the proprietary drivers to unlock full access to NVENC hardware encoding. That said, as much as I hate to admit it, I could have just used the proprietary NVIDIA drivers across the board and not dealt with any version juggling or performance regressions. Everything just works, and that stability might matter more than a few extra frames in your favorite game. So if you spend 25% of your time gaming and 75% doing other GPU heavy tasks, the simplicity of a single consistent driver experience might tip the scale in NVIDIA's favor. But to be clear, proprietary drivers only become necessary on either platform if your workflow depends on access to the GPU's full media encoding and decoding stack. If that's not something you need, the open source drivers are more than enough, and they're improving faster than ever. If you found this helpful, guys, make sure you hit that like button. It really helps the channel. If you want to see more deep dive Linux hardware content like this, consider subscribing. I've got more hardware testing, Linux PC builds, and distro challenges coming soon, so stay tuned. Thanks for watching, and I'll see you in the next one.